Hello, everybody. It is May 6th, and we're going to do some science today. Okay, so something we've already talked about, but we're going back over everything in this last couple of weeks. So, we're going to talk about plate tectonics. Okay, so how is Earth's crust changed by plate movements? Well, plate tectonics, welcome to the greatest show on Earth. Propelled by intense heat simmering beneath the crust, or the mantle, Earth's surface is dramatically reshaping itself in an endless, slow motion movement called plate tectonics. Tectonic plates, or huge slabs of solid rocks, separate, collide, and slide past each other, causing earthquakes, feeding volcanic eruptions, and raising mountains. Scientists now have a fairly good understanding of how the plates move and how such movements relate to earthquake activity. Most movement occurs along narrow zones between plates, plate boundaries, where the results of plate tectonic forces are most evident. So, the plate boundaries, that just means where two plates meet up against each other. They're either going to be moving away from each other, causing valleys and rifts and trenches. They're going to be sliding into each other, causing mountains. Okay, usually one will go under. Okay, one will go up, or they'll be sliding past each other, which causes lots of earthquakes and rumbles. Okay, all right. So, divergent boundaries. All right, where the crust is generated as the plates pull away or separate from each other. So you see how they're pulling away, they're separating, they're going. Okay, that's a divergent boundary. A convergent boundary is where the crusts come together. One crust is destroyed as it dives under another, known as subduction. Okay, an example: subduction, Marianas Trench, the mountains of volcanoes. Okay, up here, the divergent boundaries, the mid-ocean ridge, the rift valleys. Okay, so you see here, they are colliding and one goes under the other. Okay, all right, transform boundaries are where the crust is neither produced nor destroyed as the plates slide horizontally past each other. Okay, the San Andreas Fault, right, in California. You see here, they're not pulling away, they're not colliding, they are moving past each other. Okay, all right. Plates move apart. Let's learn a little bit more about divergent boundaries. Okay, we're right here. Sorry. Atlantic Ocean. Along a global system of mountain ridges, Earth's plates are growing and spreading apart. Each year, these oceanic, which means under the ocean, spreading ridges erupt more than 3 times as much molten rock as do all the volcanoes on the land. Magma rises from the Earth's mantle at spreading ridges and cools on and beneath the ocean floor, adding to the plates on either side. The growing plates inch away from the ridges, widening ocean basins and rafting apart entire continents. That's pretty crazy, guys. Look here, under the ocean, plates are moving away, and it says more magma comes from these ridges than all the volcanoes on the land. Okay? So that's a ton of magma. You see, they're moving apart, and as they move apart, that magma comes through in this little trench here. Okay? That is a divergent boundary. Now, I know your pictures might not be the clearest because his school printer is an old school printer, the copier, and it makes everything really dark. Okay, but you can see here there's the ocean. Okay, you can see this is that liquid rock, that magma that's underneath, and then these are the plates that float on top. We talked about how they float on top like spaghetti-o noodles on top of hot spaghetti. Okay, and they kind of drift apart from each other here. That spaghetti sauce goes. Okay, all right. Plates come together in convergent boundaries. Where plates come together or converge, we see some dramatic manifestation of plate tectonics. At convergent margins, continents grow as plates are consumed. Okay? All right? So you see here we have a couple different types of these, all right? And we're going to talk about these in a second. But if you look here, see this mountain range? It's caused because this plate and this plate are going into each other, and this one's going under, so it's pushing this one up. So it pushes this one up, and it causes a mountain, okay? And it can happen under the ocean too. So, three types of convergent boundaries. Convergent boundary between continental and oceanic crust results in subduction, volcanoes, and trenches. So you see here, out here, there's a little trench, okay, and living near the ocean, okay, we can see these a lot in the ocean. When a plate comes into a land plate, into a continental plate, all right, the one that goes under causes a trench right here out to land. So while the beach might be real shallow, if you go out here, there's a big, deep trench, okay, all right, and then there's a mountain that's not too far off of the coast. Convergent boundary between two oceanic crusts results in subduction, and the trenches formed are deeper, like the Marianas Trench, which can sink Mount Everest. So this is under the ocean when they're hitting each other, and they can also cause trenches because one goes up, one goes down, all right? And it says it's even deeper than the ones that are continental to oceanic because they're both underwater. Okay, so this is like the Marianas Trench. It's super deep. You could sink Mount Everest in this trench. That's how deep it is. Okay, and then a convergent boundary between two continental crusts results in building up the rocks forming mountains like the Appalachian and Himalaya mountain ranges. Okay, so you see this, when you have two land plates hitting each other, it causes really, really big mountains. We had a couple mountains form here, but these are like the biggest mountains that you'll see, okay? You'll see the Rocky Mountains, the Appalachian Mountains, where, you know, Mr. Alt went to college in North Carolina, and the Appalachian Mountains are right there, and they're huge, okay? And they go all the way up the North America, okay? They go all the way up the country. So, and that's from two land plates hitting each other. All right. So if we come back here, we're gonna finish up some of our information, and then we have some questions we can answer. Okay. All right. Why do earthquakes shake California? The state straddles two plates that are moving past each other like trains on opposite tracks. The plate boundary is marked by a zone of active faults, breaks in the rock and ground surface caused by plate movements. The most famous of these is the 1,200 kilometer, that's 750 miles long San Andreas Fault. San Andreas Fault is a transform fault, a kind of common in the seafloor but rarely found on land. Okay, so you see right here, that's the San Andreas Fault. Okay, and like they said, it's not that they're colliding, it's not that they're moving apart, it's like they're two trains going the opposite directions. They're going, but they're touching each other. So they're rubbing against each other. Like, that causes lots of earthquakes, okay? And they actually say what might happen someday is part of California could be out here in the ocean, okay? So they could be like a little island California. It would be kind of crazy, all right? Okay. And that is a transform boundary. See this picture right here? One's moving this way, one's moving that way. Lots of earthquakes. All right, so now we're going to answer these questions, okay? And we're going to use our text, right, which is the sheet attached here, to answer these questions. So what is plate tectonics? Well, it's the first question, so I always go back to the first paragraph, okay? All right, and a little hint, always the bold words usually help a little bit, okay? So Earth's surface is dramatically reshaping itself in an endless slow motion movement called plate tectonics. I like that. So if you want, write this whole thing, okay? But as long as you know what it means, I would even more appreciate if you put it in your own words. Earth's surface is dramatically reshaping itself. Earth's surface is changing in an endless slow motion movement. Earth's surface is changing in a slow, never-ending movement. Okay? So it's changing in a slow, never-ending movement. Okay? Just like SpaghettiOs. Slow, never-ending movement. Okay? So right here, I'm going to write Earth's surface is changing in a slow, never-ending movement. See, I put that in my own words, guys. Okay, try to put it in your own words. Okay, in a whole sentence. Period. How is the Earth's surface affected by the movement of tectonic plates? Okay, well, let's see. How is the Earth's surface affected? Okay, what does it cause? What do these cause? Separating, colliding, sliding past each other. What does that cause on the Earth? Well, causes earthquakes, feeds volcanic eruptions, and raises mountains. I say that's pretty good how it affects. Okay, right? If you have something on your body, because you know the Earth is like a whole body, that's causing volcanoes and earthquakes and trenches, then I'd say that thing is affecting you. So yeah, these tectonic plates affect the Earth. Okay, so they cause trenches, earthquakes, mountains, and volcanoes. Okay, the big ones, right? Trenches, earthquakes, mountains, and volcanoes. Where do most movements happen in the Earth's crust? Okay, so this is if I have some plates here, okay, we'll say this is the Earth, and I got, and then, say I have 3 plates, okay? Plate number 1, plate number 2, plate number 3. What this is asking is, where does most of the movement happen? Does it happen like right here in the middle of this plate? Does it happen at the top of the plate, at the bottom of the plate? Or does it happen at the boundaries between 2 plates? Do. You're correct! Okay, the boundaries of 2 plates, that's where they're either moving apart, they could be moving into each other, or they could be sliding past each other, right? So it's the boundaries. Okay, how do you spell boundaries? Well, if we go back here and look here, we see boundaries, okay? If you don't know how to spell a word, especially when you have a worksheet, have some sort of text, find the word, okay? B-O-U-N, dairies, okay? All right, so at plate boundaries, B-O-U-N, dairies. Okay? Boundaries. Boop. What are 3 types of plate boundaries? Well, I know this. I know one's right here, transform. Divergent, convergent. I know it's not the book or the movie Divergent. Okay, it's a boundary. Divergent, convergent, and transform. Divergent, convergent, and transform. Mr. S there. Okay. All right. Now we have some matching to do. All right. Now, this is going to ask us some questions. We will need to go back and look, especially, guys, just a little highlight these examples. It gives you really good examples here that you can use in these questions. Okay. All right. So, matching type. Plate boundaries. All right. So, it's going to ask, what is each of these different boundaries? A convergent, divergent, and a transform. Okay. So a convergent, that's where they're coming together. Okay, if we look here, convergent, an example is a subduction, Marianas Trench, mountains, volcanoes. Okay, subduction, trench, mountain, volcanoes. That one, boom, boom, bing, 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 bing. I like it. Okay, C, convergent. How about divergent? Let's see what the paper says here. What are the examples for divergent? Mid-ocean ridge, rift valleys. Okay, let's see if we can find that. Oh, look at that, mid-ocean ridge, rift valleys. Did Mr. Alt find where they pulled these questions from? The examples are very big in this, okay? All right, so this for divergent, we're going to go A. All right, and then transform boundaries. Let's see, transform boundary examples. San Andreas Fault, okay, faults. Fault lines, okay? So it doesn't say San Andreas Fault, but it's any kind of fault, okay? It's not your fault. Believe Mr. Alt. I'm a poet and I didn't know it. All right, so B would be fault lines, and that is a transform boundary, like the San Andreas Fault. You see how I kept going back here to my types of plate boundaries, and I used these examples, okay? And even if it didn't say exactly, which some of them said exactly, mid-ocean ridges, rift valleys, mid-ocean ridges, rift valleys, but I had to use my brain here because San Andreas Fault is not the same thing as fault lines, but you can see that it is related because it is a fault. All right. Matching type, let's go here to plate boundaries, okay? And here's some other things, okay? It's going to ask what does each boundary do, all right? So a convergent boundary, all right? Convergent, they come together, all right? Come together right now. The answer's B. All right. So convergent boundary is tectonic plates come together, all right? Divergent boundaries. Let's look over here, okay? And here's a hint. Look at the yellow parts for this question. Divergent, pull away or separate, okay? And move apart. Is moving apart the same thing as separating? I think so. Let's see what the other answer is just to make sure. Sliding horizontally. That's not moving apart, okay? That's not moving away. So A is the best answer for divergent, okay? And then transform. We can use the process of elimination, which means we've already used boom and boom, okay? So we only have one left. So C, and it is correct, okay? Tectonic plates slide horizontally past each other. Look at that right there. Okay. All right. Here we have a couple more examples, right? And these are more specific examples. So here it kind of gave you types of examples, like, yeah, any kind of valley, any kind of ridge, any kind of fault line, any kind of volcano. These are very specific things, okay? But you know that if it's a mountain, it is convergent. If it's a fault line, it is transformed. If it's a ridge or a valley, it is divergent. No matter what its name is. It could be the Mr. Alt's classroom mountain. That is a convergent. It could be the Miss Milliken's backyard fault line, and that is a transform, okay? So you see how no matter what the name is, it will tell you what kind of thing it is, okay? What type of landform it is, okay? Whether it's a valley, a mountain, a ridge, a volcano, okay? And that tells you which boundary it is. So convergent boundary, we're looking for subduction, trenches, mountains, and volcanoes, okay? So we have the Himalayan and the Appalachian mountain ranges, okay? That, my friends, is a mountain. Mountains are convergent, okay? So we're going to go with A. All right, divergent, okay? Divergent, remember, we're looking for fault lines, all right? Okay, so fault lines. Are any of these a fault line? Is the African Rift? Not a fault line. San Andreas Fault. Boom. Yep. All right, we got a fault line. And then process of elimination. Okay, Atlantic, Mid-Atlantic, Atlantic Mid-Ocean Ridge, African Rift Valley. Okay. Ooh, I messed that up. Okay, so C, we know C is divergent. Okay, because that's in got mixed up here. Transform is definitely our fault. Okay, because fault lines is transform. So San Andreas Fault is definitely transform right here. So we have A, C, and B. Okay, I was just testing you guys, see if you could tell me if I was wrong. All right, so next one is convergent boundaries, and we're going to talk a little bit more about some different examples. Continental to oceanic. Okay, so this now we're only talking about convergent boundaries to come together. And remember, we have three different types: continental to oceanic, oceanic to oceanic, continental to continental. Okay, and there's three different things that form. Okay, subduction volcanoes, trenches, deeper trenches can sink Mount Everest, and mountains. Okay, all right. So let's see. Continental to oceanic. That causes, you can see here, continental to oceanic, subduction volcanoes, trenches. Subduction volcanoes, trenches. So A works for that one. Okay. Oceanic to oceanic, these are these really deep trenches like the Marianas Trench. Okay. Deep trenches. Okay. Deeper trenches, volcanoes, right? Very good. B. And then the last one, we know process of elimination. You guys are getting so good at process of elimination. Okay, we have one answer left. We have one place to put it. So this is C. Okay, and it is mountain ranges. Okay, See right here, that continental makes those mountain ranges. All right. So, a couple more things right here. Why do earthquakes shake California? Let's see. Why do earthquakes shake California? The state straddles two plates that are moving past each other. I like that. That's a perfect answer. Because the state is right on two plates that are moving past each other. Okay? So you put it in your own words. Okay? The state is located on two plates moving past each other. Bingo. What is the San Andreas Fault? Okay, what is the San Andreas Fault? Okay, it is a break in the rock and ground caused by plate movements. Okay, because remember, that is a fault. Okay, marked by a zone of active fault, a break in the rock and ground surface caused by plate movement. So it is a break in the rock caused by plate movements. Okay, and you have them things moving around, that rock's gonna break, and that's gonna cause a fault line. Okay, now we get to draw. Woohoo! I know there's some artists out there that are really good at drawing. Go for it and make this your best drawing ever. If you're like Mr. Alt and you're not the best drawer ever, just do your best to show me. Okay? I'm not grading, and it's not anything about how great of an artist you are. It's, can you put in your mind what you see for the answer on paper? Okay, so illustrate the movements of the different types of plate boundaries. Use arrows and indicate directions. Arrows is big here. Use the arrows. Okay? All right, so we're going to do convergent. Got a label. Okay? Convergent, divergent, and transform. Okay, watch Mr. Alt's artistic magic. All right, my fault line is going to be a squiggle. I know, you've never seen such a squiggle in your life. It's the best squiggle ever. All right, and convergent is when they're going to move together. So my arrows are going to have these plates moving together. Look at that. Convergent, moving together. Guys, I think I have my masterpiece right here. All right, next one. Guess what? Still the squiggle. Okay, that is a great squiggle. I've outdone myself. All right, now they're going to be moving away. Okay, so I need to make my arrows going away. Okay, here are my arrows. All right, and then transform. Okay, so for this, we need to go beside each other. Like, all right, just had some technical difficulties there, but like I said, beside each other, okay, like that train. So one's going up, okay, and one is going down. All right, that's the transform boundary. So you can see, not the best artist ever, but did I show you guys what the plates were doing? Yes, and that's all you need to do here is show what the plates are doing. If you'd like to draw some what happens when they transform in fault lines, if you want to draw some cracks in the ground like a San Andreas fault. Divergent causes rifts and valleys. If you want to draw a valley here, you can do that. Okay, if you want to make mountains here in this convergent boundary, go ahead. Okay, but if you just want to do what Mr. Alt did here, that shows me what is happening at each fault. Hey guys, it's Mr. Alt. Did you enjoy that video? You finished your work for the day and wish there was just something else you could do? Our Microsoft Teams page, available on your computer or on your phone or tablet, and come to the left and click Enrichment Opportunities, and there's lots of extra things here for acting, art, science, history. You'll see our Jeopardy games. Lots of fun stuff to do if you finished your work for the day. It's extra, so it's not mandatory, but it is there for you. Okay? Enrichment Opportunities under Mr. Alt's class. Have a good one! All right, so for this, technical we need to go there, but beside each other. Like I said, beside each other, okay, like that train. So one's going up, okay, and one is going down. All right, that's the transform boundary. So you can see, not the best artist ever, but did I show you guys what the plates were doing? Yes, and that's all you need to do here is show what the plates are doing. If you'd like to draw some what happens when they transform in fault lines, if you want to draw some cracks in the ground like a San Andreas fault, divergent causes rifts and valleys. If you want to draw a valley here, you can do that. Okay, if you want to make mountains here in this convergent boundary, go ahead. Okay, but if you just want to do what Mr. Alt did here, that shows me what is happening at each fault.